Hey class, welcome to lesson 7.8, Compare Mixed Number Factors and Products. Let's take a look at our essential question for today's lesson. How does the size of the product compare to the size of one factor when multiplying factors greater than 1? So the first thing that we need to do is to take a look at our word problem. It says you can make generalizations about the relative size of a product when one factor is equal to 1, less than 1, or greater than 1. So we're going to look at two different ways. The first way is to use a model. So Jane has a recipe that calls for 1 1/4 cups of flour. She wants to know how much flour she would need if she made the recipe as written, if she made half the recipe, and if she made 1 1/2 times the recipe. So we're actually looking for three different things. How much flour she would need if she did it as written with the recipe, if she made half the recipe, or if she made 1 1/2 times the recipe. So three different things. So the first step that it's going to have us do is to shade the models to show 1 1/4 scaled by 1, by 1/2, and by 1 1/2. So the first thing is we're going to do it scaled 1 times 1 1/4. So, to show the model with the 1 1/4, we need to look at our whole number of 1, which means we need to shade one of these holes till we demonstrate the whole number of 1. Now, if we look at the fraction part of it, we see the 1/4. Well, we know the 4, the denominator, tells how many pieces it should be broken down into. So as you see, we've broken it down into 4 equal pieces, or work with me, they're close enough to equal. Our numerator tells how many pieces out of those 4 that need to be shaded. And we see that our numerator is 1, so we're going to shade 1 piece out of the 4 to demonstrate 1 1/4. So now the question says, what can you say about the product when 1 1/4 is multiplied by 1? Well, this answer should have been pretty easy for you because the identity property of multiplication, says that any number multiplied by 1 is that number. So the product will be equal to 1 1/4. So now let's take a look at the next one, 1/2 times 1 1/4. So let's kind of shade our models to demonstrate the 1 1/4. Of course, the 1 is going to give us the whole number, so we need to shade the whole box to demonstrate the 1. And then, of course, when we're looking at the fraction, we see 1/4. The denominator tells us how many pieces we need to divide it into. And shade, we have a numerator of 1, so we need to shade 1 piece of it. Now, the next piece of it, we have to look at our other fraction of 1/2. And of course, we know that our denominator tells us we need to divide it into 2 pieces. So we have our 2 pieces, and that we need to shade that piece, 1/2. So we're going to shade, and we're going to shade. So now it asks, what can you say about the product when 1 1/4 is multiplied by a fraction less than 1? And let's think about that. It should be the product will be half of what I started with. So let's see if that's the case. So when we look back up to here, we see that when we multiply 1 times 1 1/4, it equals 1 1/4. Now when we look down here at 1/2 times 1 1/4, and we look at the pieces that are shaded twice, we can see that when we multiply 1 1/4 by a fraction less than 1, the product will be less than 1 1/4 because the area shaded twice is less than 1 1/4. So let's take a look at our last one. It's 1 1/2 times 1 1/4. Now that's going to equal 1 times 1 1/4 plus 1/2 times 1 1/4. So let's demonstrate that by modeling it out. So let's start with the first part, where we have in parentheses, because of the distributive property, 1 times 1 1/4. Well, if we look back up here, we see that to model that, we need to shade one whole, and our denominator tells us how many pieces we need to break down the second piece, and that is 4, and our numerator says to shade one of those 4 pieces. Now to look at the second part, we have 1/2 times 1 1/4, and that's going to be modeling this example again. So we know that we need to shade one whole and 1/4. So let's start with that. Now the other fraction, 1/2, has a denominator of 2, so we know that we need to divide each piece in 2 and shade it, one piece out of those 2. Divide this one into 2 and shade one piece out of that. So now we're looking at everything that we have shaded. So the question then becomes, what can you say about the product when 1 1/4 is multiplied by a number greater than 1? And as we've demonstrated by our models, the product will be greater than both factors. So just to recap, when we're multiplying by 1, the product will be equal to that number. When we're multiplying by a fraction less than 1, the product will be less than that number. When we're multiplying by a number greater than 1, the product will be greater than both factors. Kind of helps you know, serve as a check to see if you're getting the right answer. Okay, let's take a look at another way to compare mixed number factors and products. And this way is to use a diagram or a number line, as we like to refer to it. So let's take a look at our word problem. Jake wants to train for a road race. He plans to run 2.5 miles on the first day. On the second day, he plans to run 3/5 of the distance he runs on the first day. On the third day, he plans to run 1 2/5 of the distance he runs on the first day. Which distance is greater? The distance on day 2 when he runs 3/5 of 2.5 miles, or the distance on day 3 when he runs 1 2/5 of 2.5 miles? So let's start. Graph a point on the diagram to show the size of the product. Then complete the statement with equal to, greater than, or less than. So let's take a look at it. It's asking 1 times 2.5. So let's plot that out on our number line. So the first step is to take a look at both of our factors. We know that our second factor in our multiplication problem tells us exactly how far we need to jump each time. So we're going to go our 2.5. So we're going to move over to our 2.5 on our first jump. Now, the first factor in our multiplication problem tells us how many jumps on the number line we're going to make. The second factor says how far, the first factor says how many. So we have a factor of 1 so that we know our first jump is going to jump 1 time and he's going to jump 2.5 at that. So the product of 1 and 2.5 will be equal to 2.5. So now let's take a look at our next one. 3/5 times 2.5. Now this one gets a little bit more complicated. So we know that the second factor tells us how far. So let's go over to our 2.5. Now our first factor tells us how many jumps he made. And it is a fraction of 3/5. So we know he didn't make a whole jump. So let's kind of jump over 3/5 of a jump. And you'll see our dot on the number line shows us where we ended up. So the product of a number less than 1 and 2.5 is less than 2.5. And let's take a look at our last one. It says 1 2/5 times 2.5. And keep in mind, with the distributive property, we can do 1 times 2.5 plus 2/5 times 2.5. So let's plot that out on our number line. So let's go over to our 2.5. Now we have to make our jumps. So we have one whole jump that we need to make, which takes us to there, and now we have 3/5 of a jump left to make, which is going to take us to here. That's where our spot is on the number line. So the product of a number greater than 1 and 2.5 will be greater than 2.5 and greater than the other factor. So 1 2/5 or 2.5 miles is a greater distance than 3/5 or 2.5 miles. So don't forget about your password. Our password for today is to name the 2 ways we learned today to compare mixed number factors and products. The first way we learned was to use a model, and the second way we used was to use a diagram or number line. Be sure to write those down and bring them with you to class tomorrow. See you then.